Hey, good afternoon, everyone. Thank you for being here and attending the session. My name is Chris Patrick, and I'm thrilled to be here today to talk about how we can leverage some pretty amazing features of FactSet and Snowflake together. Today, I'll be demoing how we can build some pretty cool things with much less complexity than we would have in the past. Since I only have about 20 minutes here, let's just dive right in. All right. As I said, my name is Chris Patrick, and I'm a principal business intelligence engineer with Continuus Technologies. I've been with the firm for about 4 years and have been doing data in financial services for a little over 12 years now. Please do feel free to connect with me on LinkedIn, reach out with any questions, thoughts, or anything like that. I really do welcome it. So at Continuus, we provide a full stack of data expertise with a really intense focus on financial services. We really seek to develop those long-term relationships with our clients and really become trusted advisors. And we're helping out not only with engineering and project execution, but also with things like data strategy and data governance. So part of our mission within what we term as the Financial Services Data Cloud is to really focus on delivering capabilities. So we have partnerships and good relationships with some of the best-in-class vendors, and we're actually one of the select few firms that are partnering directly with FactSet as an official systems integrator partner. In addition to that, we've been ranked as one of the top Snowflake partners in the industry, and we're premier partners with Snowflake, and we've earned the Financial Services Industry Competency ranking from Snowflake. So really what we're looking to do today in this session is to show what this means in the real world. So we're going to move beyond some of these buzzwords of integrating data, breakneck speed, all that, and we're going to look and see what we can build in 20 minutes that will actually sort of live up to these claims. So with that, I'll kind of jump into the premise of what we're going to be looking at in today's demo session. So like any good analytic project, it always starts with a question. In this case, what if we could turn the FactSet estimate surprise screen into a machine learning driven model that gives us a programmatic function that we could use to actually deliver signals to analysts. So if you're not familiar with this particular page in the FactSet terminal, this screen really summarizes the broker-provided sell-side consensus estimates. So as companies go through their earnings cycle, the sell-side brokers are publishing models and revising the estimates as they get closer and closer to the reporting period. And then the company will report their actual results, and there will obviously be market implications because of that. So in this case, I pulled up Pepsi. I apologize that this screenshot is a little bit small, but just a couple of the key columns that we're looking at here. We can see that for the June 30th period for Pepsi, there were about 17 or 18 sell-side firms providing estimates. We can see the range of the estimate. In this case, we're looking at the earnings per share metric. We can see what the average was, and then we can even see what the actual was. So this after event column is what the company actually posted. And then some resulting columns from that are the surprise percent. So literally just the percent difference between what was estimated and what actually happened, as well as the price movement for the 3 days following that event. So again, in this case, we're looking at that June 30th quarter. We can see that there were a number of brokers providing estimates. Those estimates were revised over time, and the company ended up reporting higher than estimated, which led to a positive price change. So to do this analysis, what we're really going to be doing is combining the depth and breadth of FactSet's estimates data with the scalability and extensibility of the Snowflake's compute platform. So let's dive into the architecture diagram here. As I said, we're going to really be focusing on how little complexity there is. So that's why this beautiful, lovely PowerPoint diagram is very simple. So we'll be leveraging the FactSet estimates as they're provided from directly from FactSet and made available via Snowflake data share. And once we have that data share consumed and brought into our Snowflake cloud environment, then everything that we're doing from end to end will live within the Snowflake UI. So there isn't any development environment to set up. There's no packages to install on your machine, nothing like that. So we'll be setting up a couple SQL views to prepare the data to feed into our model. We'll be creating a Python worksheet within the Snowflake Snowpark environment that will actually build the model. There will I won't train it live because we don't need to sit there and watch code run, but I'll show you the code that I use to train the model. And then finally, we'll create a Python UDF, or user-defined function, that will wrap the prediction call into a function that we can then use in any SQL query. So in the same way that you use, a get date function or convert function, we'll be able to say, give me a model result for the set of inputs. So hopefully that all makes sense, and I haven't skimmed anything too much from my notes here, but let's start getting into it. Real quick, just need to say it, this is not investment advice. Don't trade your money this way, or at least not based on my recommendation. All the data is coming from FactSet. It's only demo purposes. And the model is intentionally designed to be simplistic and is not representative of any client research or any proprietary research whatsoever. Again, just all demo here. I think we all know that. So that being said, let me flip over to my Snowflake window. One moment here. Okay, so hopefully you all can see my Snowflake screen here, but I am now in the Continuous Technology Snowflake environment. And if you're not familiar or haven't worked with Snowflake much, what we're consuming is a data share. So as I said, this data is shared with us directly from FactSet. So there is no ETL process, there's no latency, there's no middle layer between the FactSet data and us. We have our licensing agreement in place, and the account admin role is able to just say, yep, let's consume it. So now this database, which is entirely managed by FactSet, is available in our Snowflake environment, just as any other database is. So here, FactSet, they pay for the storage, and any compute that you use to interact with the data, you pay for that compute, as you would with any other database. And if you're familiar with the on-prem data feed loader for on-prem databases, you'll see that this is the exact same schema, exact same product. Here we have lots of different products, but we'll be focusing in on the FE, or FactSet estimates schema. And just to show these, so we'll really be looking at the FactSet estimates. Where's my table here? FactSet estimates for basic estimates, looking at the consensus history for quarterly financials. All right, so I believe that covers the FactSet data share. And now we can flip over to our to the actual demo. So there's a couple, there's 4 tabs that I'll walk through here. High level, first step, we have to gather the data that we're going to model. So I'll do that by defining a list of companies. In the real world, this would be your investable universe, your portfolios, your accounts, whatever it may be. In this case, it's just a list of the top 500 companies because they'll be familiar to us. I'll create some SQL that will define the inputs and outputs, and then we'll create a view that will be used to load those into the model. The next step, once we run through that, we'll be actually running through the Python code that we use to build and train the model. Finally, we'll build that UDF that we talked about, the user-defined function, and then we'll use it and play with it. So let me, apologies, I should have had this started before, but now that our warehouse is started and we're all fired up, we don't need to go through these items line by line, but in general here, we're just selecting the top 500 company names as our company list. And so we're bringing in their IDs, their name, and we're just sorting by market cap, a very rough approximation of market cap. Not looking for perfection here, just gathering a list of companies that we're interested in, focused on the companies that are listed on either the NYS or NAS exchanges, and then any companies that are obviously active. So that, running through that, I'll just show the outputs here. Again, we don't need to sit here and watch code run. This will give us our 500 rows, and we'll see our common names here: Apple, Microsoft, Google, Amazon, for the top 500 companies. So now these companies are the firms, or the companies that we're going to go out and get the estimates data for. So now the fun really starts. So this next table here is going to contain the aggregated estimate revisions, including the 3-day return. So I broke it up into a couple different sections in this query. The first section is, like I said, aggregating those consensus history estimates. So for our top 500 companies, I'm going through and grabbing each of the fiscal periods and then each of the revisions within those fiscal periods. So for a particular quarter, there may be 20 or 30 different revisions that happen before the company actually releases their numbers. So those revisions are all published by the brokers. FactSet does their magic to consolidate those, aggregate those, align those, and as soon as they're done, it's then available in our data share database. So again, we'll just kind of talk about it high level. So here I'm just doing a count to get the total number of revisions. They have a column for how many, for a given revision period, how many were up and how many were down. So I get that raw number. I also calculate it just as a percentage. And then we also pull in from the actuals table what actually happened. So for the same fiscal period, same company, same item, we can get the actual value, and that will allow us to compute that surprise percent. So the difference between what was estimated and what actually happened. And really importantly, it also gives us the date that the actual values were reported. So as I go through and capture the performance, we have the date, correct date. So skimming through here a little bit, we also get the first and last consensus value that will allow us to do a percent change of the values over time. Last little bit here is getting our daily returns. So we get the 3 trading periods after the report date, and that will end up being our target variable. So finally bringing us all together, I'm just going to show the rows for one company here. Bringing that all together, we get our company name, some identifiers, fiscal period, what we're presenting, and then, like I said, those columns that we saw on the surprise screen. So we see our 18 estimates, what the actual was, the number that were up, that were down, percent change, the surprise percent, and then the performance period. The environment that we're working here has some embargoed data, so I do have some missing data points, but that does not affect what we're talking about. And then finally, I create the view that is the input view for the actual model. So really all I'm doing here is excluding anything that we're missing data, excluding some of the outliers, and most importantly, excluding the actual values. So I don't want the model to be trained on future knowledge. So it's only being trained on these factors that are coming in. So now we can flip over and look at our Snowpark. So this worksheet here obviously is not in SQL. We're not in SQL anymore. We're now in Python. And within this Python script, we can import the packages as needed. So I'm using scikit-learn as the modeling, and then obviously pandas, numpy, so on and so forth. So this is now, it now functions as any other Python script that you've ever written, with the only sort of nuance is that the entry point is a function named main that takes a session variable. So again, not going to go through this line by line, but here we can see that we're using that view that we created as our input. Our target column is the 3-day %, and then the stage name, or where we're going to save the actual model, is specified here. So we run through this. This line here, we're creating the training and testing data frames. So we load in all that data from the view, split it 80-20, 80% to the training, 20% to the testing. And then I do some manipulation on the columns to exclude our target column, exclude the date, exclude the ticker, just some really basic data preparation to run it through the model. This is honestly pretty, I don't want to say boilerplate, but I was heavily influenced by the public samples for what can be done on some data sets on the Snowflake GitHub page. So then finally we fit our pipeline, and then we actually run the model there, and we save the model into a Snowflake folder. So it's saved in Snowflake, and we give it the name. There's some other helper code here. The model type, just for your reference, that I'm using, it's called a random forest regressor. I have one categorical variable, which is the sector, and a handful of numeric variables, such as number of estimates, % up, down, % change. So then the last little bit that we need to do is, now that we have that model generated, let's wire it up so that we can call it in Snowflake. So here we create a function called estimate revision return model. We take our input parameters, we specify what packages we'll need. These are similar to the ones that we saw in the session. We give it the file path to the actual sklearn model joblib file, and then we give it the handler, the function that's going to run. And this handler is literally 3 lines. We read the file that we said we're going to read, we create a data frame from the input, and then we call the predict function and return the results. So with all that, now let's see what actually happened. And I realize that I am very quickly coming up on time. So then, looking at the results here, I can call the function directly within a SQL query. So now this estimated 3-day % column is the result of the model. We can see the actuals, and directly within Snowflake, we can chart our actuals versus estimate. So we can see that we've done pretty good there. And well, I would spend a little bit more time showing what we could do on this. I am going to flip back just to my results summary here. So in the total development time, training, and using the model, I consumed 3.4 credits on Snowflake, which is about $7 or about 1 grande pumpkin spice latte. Incurred $0 of storage cost, wrote 0 lines of code, 0 seconds of latency between FactSet releasing the estimates data and it being usable in this model, 0 dependencies, and literally if we ran the code from start to finish, it would run in less than 5 minutes for generating that model, training it, and having it be usable. So all that said, I believe I'm right at time here. So I want to thank you for going on that very, very fast journey with me. And hopefully that was a good example of some of the capabilities that we can do on this platform, and just how we can reduce complexity in delivering real signals to real users. We can now use that function in queries that we present in dashboards, and that's really cool. So I do want to thank you for your time and attention. And like I said, please do reach out to me directly if you have any questions, any thoughts, comments. And if this is something that you're interested in, we'd be happy to help you build it on your own. So with all that, thank you very much.